You know that classic office battle, right? The fight over the thermostat. It feels like a universal struggle. But what if I told you the entire rulebook we've been using to decide the perfect temperature is, well, just plain wrong? There's this incredible new study that's flipping decades of thinking on its head, and it all boils down to one really simple question.
So what is it? Is it a cool 21 degrees Celsius, maybe a cozier 24? For ages, these global standards have tried to nail down one single perfect answer for everyone. But when a team of researchers in India actually put those standards to a real-world test, they stumbled upon something that could literally change how we build our homes and offices forever.
Okay, get ready for this, because here's the bombshell. In this massive study they did in India, a staggering 90% of the people who said they felt perfectly comfortable were in rooms that our official standards classify as uncomfortable. I mean, that's not just a tiny mistake, right? That's a massive fundamental disconnect. So what in the world is going on here? All right, so to really get our heads around that 90% number, we've got to back up a bit and look at the official standard itself. For decades, the whole idea has been to find this one-size-fits-all solution, a single, universal comfort zone that's supposed to work for absolutely everyone, everywhere. And that standard has a name. It's called ASHRAE 55. Think of it as the official rulebook for what makes a room feel comfortable. It was developed in the US, but it's used all over the world, telling architects and engineers the exact temperature and humidity range that's supposed to keep most of us happy. But here's the really crucial part. It's how this rulebook was written. It's all based on something called a steady-state theory, which came out of tests done in these super-controlled lab environments, climate chambers. So just picture it. You're in a completely sealed room, the temperature never changes, the air is perfectly still. That's the world this standard was born in. But, let's be real. How many of us actually live or work in a place like that? And that, right there, is the heart of the problem. The standards world is one of sealed, air-conditioned boxes. But this study, it happened out in the real world, in naturally ventilated buildings. Places where people can actually open a window, turn on a fan, and where the temperature naturally goes up and down during the day. And that, it turns out, changes absolutely everything. So let's head to Jaipur, India, which is where this whole story unfolds. It's a city with what they call a composite climate, which is a nice way of saying it has brutally hot summers and pretty chilly winters. And when the researchers took that global one-size-fits-all standard and tried to apply it here, well, the results were definitely not what anyone saw coming.
And look, this was no lab experiment. The team went into 32 actual, real-world buildings over 4 whole years. They were there when temperatures soared over 45 degrees Celsius in the summer and when they dropped below 4 in the winter. They were basically putting this universal comfort standard through the ultimate stress test.
So, we're right back to that huge disconnect. You've got real people saying, yeah, I feel fine, sometimes in rooms that were well over 30 degrees Celsius. But at the same time, the official ASHRAE 55 rulebook is over here basically waving a red flag, saying these conditions are totally unacceptable. So the big question is, why did the standard get it so incredibly wrong?
Well, the answer is actually pretty simple and kind of beautiful. It's because we, as people, adapt. So this study threw out that old, rigid, static model and instead embraced something called the adaptive comfort model. And the whole idea behind it is that we're not just passive thermometers sitting in a room. We actively do stuff to make ourselves comfortable.
And when I say they listened, I mean they listened on a huge scale. We're talking more than 2,600 surveys collected over 4 years through every single season. And while they were measuring all the technical stuff, temperature, humidity, airspeed, they just kept asking thousands of people that one simple, powerful question. How do you feel right now?
So what was the first big takeaway? Get this. Across all the seasons, a whopping 82% of people said they felt comfortable. They were just adapting, changing their clothes, their routines, and because of that, they felt just fine all year long.
But wait, here's the real game changer. Comfort wasn't just about the number on the thermostat. It was all about airflow. Even when people said they were comfortable, about half of them still wanted more air moving around. They were using fans, opening windows, creating their own little personal microclimates. It proves it's not just about what the temperature is, it's about what you can do about it. Okay, so if the old map is totally wrong, what does the new one look like? Well, the researchers plotted all their data onto these really cool charts that show how temperature, humidity, and comfort all connect, We're going to call them comfort maps for short, and they really visually tell the whole story of this incredible discovery. All right, let's start with the official map. See that small shape on the screen? According to the old ASHRAE standard, that little box is the entire zone where humans are supposed to feel comfortable if the air is still. The old rules are simple. Inside the box, you're good. Outside the box, you're not.
Okay, now let's bring in the data from the real world. Every single one of these dots is a person from the study who said, yep, I feel comfortable. And just look where they are. The vast majority of them are way, way outside that tiny official box. This map isn't just a little bit off, it's completely and fundamentally wrong.
So the researchers decided to draw a new map. This first one is just for still air, to keep it a fair comparison with the original standard. But look, just by basing it on how people actually feel, the comfort zone gets way bigger. It shows that people can be perfectly happy all the way up to 32 degrees Celsius. That's about 90 degrees Fahrenheit.
But hey, remember the fans? That desire for more airflow? Well, when you factor in the cooling effect of just a simple breeze from a fan or an open window, the map gets even bigger. The upper limit for comfort now stretches all the way to 35 degrees Celsius. That's 95 Fahrenheit. Now that is the power of adaptive comfort right there.
Okay, so we've got this new, much bigger comfort map. So what? Why does this matter so much? Well, this is way more than just some interesting academic exercise. Redrawing this map has huge, real-world consequences for how we design our buildings and, frankly, how much energy we use as a planet.
I mean, let's just break it down. If people are totally fine at 32 degrees with a fan on, then we don't have to crank the AC to keep our buildings at a chilly 22 degrees all the time. That means way less reliance on air conditioning, which leads to massive energy savings. It means we can design smarter buildings that actually breathe using natural ventilation. And it means we can finally have a global standard that's inclusive and reflects how people really live all over the world.
For so long, we've basically been trying to achieve comfort by using brute force energy, like we're fighting a war against the local climate. But what this research gives us is a whole new blueprint. It's a plan for designing buildings that work with nature, not against it, and that empower people to create their own comfort with simple, smart, adaptive tools.
And really, it all leaves us with a pretty powerful question, doesn't it? What if the simple act of trusting how people actually feel, instead of what an old, outdated standard tells us they should feel, is one of the keys to building a healthier, more comfortable, and a radically more sustainable world for every single one of us?